So good morning. I'm Mr. Ngige, your trainer in solid geometry. We are going to look at solid geometry, this lesson 7. So we are going to look at our objectives. We are going to do a recap of orthographic view selections. We are going to familiarize the views of primitive of solid objects in preparation of solid geometry. We are going to identify methods of service development. We are going to illustrate radial service development and parallel line development. So you can also perform this in AutoCAD on the workspace area. Now I know we have no problem with AutoCAD so far. So as a recap, we had looked at orthographic projection view selections, the edges, the corners. So when you're talking about the edges, we're talking about these lines. The corners is where the edges meet. Then for this is for a cuboid. For a cylindrical object, you can see that the diameter or the circular forms the edge. Then we have it has no corner, so it's the circular that forms the edge. This knowledge is important. Um, um, Having looked at coming up with the elevations and the plans. So also it's also good when we have an introduction to services. There are lines that are bounded by edges or limiting elements. Limiting element is a line that represents the last visible parts of the curve service. So the service are what we have, the faces, then the limits. The limits are what are calling the edges. So it is important that we see that the limits here of a cylindrical shape looks like a rectangle. Then to familiarize with some views, you can see that if now we were to look at this face, so it's the one that we represent in 2D. Then you have the plan, it is the one that we have it here, and then we have the side represented. So for a sphere, it's the same case applies. Then for a cylinder, it's good that we know that we take the top as a plan, then we take this shape. It looks like a rectangle. So it is important, and also it's also good we borrow our knowledge on line types. So for a cone, we take the bottom, which is the plan. Then you can see the edge, whatever we have on this end. So they look like a triangle. And also you can see we are drawing a line of symmetry. So it's good to borrow from that. So the same applies to that shape, whereby this denotes that this one is circular. The face, the plan is circular. Then having looked at it from this end, the front. So we have this one showing the edges, but they're hidden details. And also showing but they are hidden details. Then we have the line of symmetry. So this one shows that we have a hollow, something hollow. Then from other direction, this is the end. So we have it represented, so by these hidden lines, and then we have the center line. So allow me now to introduce solid geometry and service development. Development of service of an object means the unrolling and unfolding of all services of the object on a plane. So the key word is unrolling and unfolding. If the surface of a solid is laid out on a plane surface, the shape that's open is called the development of that solid. In other words, the development of a solid is the shape of a plane sheet that by proper folding will be converted into the shape of the concerned solid. So surface, so unrolling and unfolding. So methods of service development, we have parallel line development, radial line development, triangulation development, approximate development. So for our discussion, we shall look at parallel and radial line development. After this, we are going to look at several examples, but to encourage you that the moment you get the, the, the understanding on um, a parallel line and radial line development concept, then it becomes easy for you to practice. Parallel line method, it is used for developing prisms and single curved surfaces like cylinders, in which all the edges, generation lateral line surfaces are parallel in each other. So the unfolding now, you can see how we are folding it, but we are unfolding it on parallel lines. So you can see the parallel lines and you can see them represented. So if at all this is a box, simply what we have is this one is showing, this one is the solid itself, but now these are the part, the ABC represent that it has been opened. Then we have one surface which you cannot see the other end. So the one we cannot see is the one we have A, B, C, D. Then you have this E and F and E represented on this surface. If you have now a cylinder, you can see it's like we are rolling. So this is like unrolling. We are unrolling, and basically what you're going to have at the end is that we are going to have a circle on top here and a circle on the other end. So the same case applies. If you have a cube, you have a cube on this point, these are the end, these are the end, the left. So this one, we are opening uh, this cube. So this one is represented by this part is represented by this. Then you have this one represented. So we have like two sides here. So this one and that. And then we have this one represented on this part. So by folding this, we are going back to this cube. So by unfolding it, this is what we have. So you can see that we are following on parallel lines. The lines are parallel. This line and that is parallel. This line and that is parallel. This one and the other one is parallel. For a triangular prism, the same case applies. So you open it on the other end and also on the other end. Then you open the triangles. You open the triangles. So at the end of the day, this is the object. So if at all you now fold it, whatever you have is now a triangular prism. So the parallel line applies to prisms and cylinders. Radial line, it is employed for pyramids and single curved surfaces like cones in which the apex is taken as center. The slant edge or generator is radius of its development. So a cone, this is the shape of a cone, and of importance, you can see that unlike the other one that had parallel lines, these ones they are appearing as if they come from a common apex. They appear to come as if they are from a common apex. And these are representations. So they are all emanating from a common apex. So that's how this one is for a square pyramid. Then for the other one is for a cone. So these are the concepts that we shall be using given a scenario. Maybe you have been given the diameter and you have been given the height. So for this one, it's good we know the slant height. But for the other one, the slant height is already given. But this one, you shall look at it as we practice. So for my discussion, we have tried to look at the radial line and the parallel line, and for solid objects that whereby radial line is used is in cones and in pyramids, but for parallel lines, they're used in prisms and in cylinders. And we have talked of the methods of service development, which is parallel line, radial line, and triangulation development. And um, we have also talked about that service development involves unrolling and unfolding. And it's good we know about some of these primitive solid objects, whereby we are going to apply these service development. So my sources are AutoCAD Basic, Orthographic Projection by Dr. Typhoon, Engineering Graphic Service Development, and we have our links by Shaika on service developments. So kindly practice the following. You can come up with this development, or we shall um, try to illustrate this on AutoCAD, but I would also encourage you to practice it on your manually. So for any demonstration in AutoCAD, I will show you, but now you know how to use the AutoCAD, so you can look at the problems which you shall look at. So with your first time, kindly subscribe. So, but if you have already subscribed, kindly thank you, like and share the video. So kindly do the following: define term, service development, explain the following methods of service development: the parallel line, radial line development, triangulation development, and approximation development. So I'll send you more problems on the practical part. So I've been your trainer, Mr. Ngige. Thank you very much. Kindly take notes because this is what you're going to look at. Thank you very much.